Good morning, this is your stats sensei, Mr. Spensei, and this is the exit ticket. Who used the pool? The Department of Parks and Recreation of certain city conducts summer programs for residents of its 6 districts. The summer programs include operating and maintaining community swimming pools in each of the district, as well as offering sports and recreation programs for school-age children, young adults, and older adults. More than 20,000 people participate in summer programs each summer. The table below shows the proportion of households by district out of all households that participated in this program based on the annual data that were collected from the simple randoms over a 10-year period ending in year 2000. That's a long time ago. The proportions are being used by the city for planning purposes and more effectively targeting the introduction of future programs. So here we have District A, 32% participated. District F, only 14%. Looks like District C had the least percentage at 10%. City leaders want to test if the proportions that are being used by the city are still the same. Are they still valid? Data collected by a statistician from a simple random sample this past summer. So we have a single sample indicated the following number of households participated. So we have all these observed values. So we have multiple groups. All right. The statistician claims that the data for the summer provides evidence the proportion are being used are no longer valid. So they're not the same, that the old ones are not the same as the new ones. All right. So which district had the greatest contribution to the chi-squared statistic? Justify your response and show the calculations for the contribution. Well, to do that, we're going to have to enter this. We're going to need to enter this as observed data. And observed is going to go into L1. And we'll put the proportions into L2, but then we're going to have to do something with them. So first off, I've already entered the observed data into L1, and I have the proportions in L2. I'm going to go stat calc 1var stats, and I find out that there's a total of 240 observed values. In other words, if I added all these up, they would have equaled 240, and that's my sample size. So I need to take these percentages and turn them into expected values, and I do that by multiplying by my sample size. I need to multiply it by 240. So going back to stat edit, I'm going to go all the way up to the top of the percentage column, which is L2, and press second followed by the number 2. All that does is highlight L2 and multiply by the sample size of 240. And now I have my expected values. Great, I have my expected values. I still don't have the answer to the which one contributed the most. To do that, I actually need to run the test. So stat test chi-squared. We want D for goodness of fit. This is a goodness of fit test, so go. Our observed is an L1. We have expected an L2, and our degrees of freedom would be 6 categories minus 1. And that came from 1, 2, 3, 4, 5, 6. And this time, we're not interested in the chi-squared values. We're actually interested in the contributions. That's contributions. That's not contraband. That's what it looks like. So we have 7.08 for our first one. 1.3 is our next one, etc. 10.66, 28.26. Be careful. We have a 0, no difference. A 0.2 is our last one. All right. So I listed those out because we have 6 values. A was 7, B is 1.33, C is 10.66, D is 28.26, E was the one that was 0, and then we have the F of 0.20. Well, clearly, this is the largest one. And I want to make one more comment. If I add up these values, they equal 47.48. They equal my chi-squared value. So they equal 47.48. All right. So District D had the greatest contribution with a contribution of 28.26. And I could have gotten that a couple different ways. I could have scrolled over And there it is, 28.269, or I could have calculated it by hand, and I'll show you how to do that. So to do that, we list our formula. Because remember, our formula is observed minus expected squared over expected. Well, for District D, we expected 22, all right? And if I go back to stat edit, I find out we expected 22, but we observed 22, but we expected 64.8. So that's where that came from. So this was my observed. This is what I expected. So here's the way you calculate that by hand. Parenthesis, 22 minus 64.8. Close the parenthesis and square that. And then just divide the result by 64.8. And there it is, 28.269. All right. Sure hopes that helps. Sure hope to see you on the next one. Thank you.